Hello, myself Professor Mrs. C.S. Nirali from Food Chemistry and Nutrition Department, KK College of Food Technology, Saraswati Nagar Campus, Nashik. And the course number FCN 357 course title Instrumental Techniques in Food Analysis. Today we will see quality evaluation of raw materials like fruits, vegetables, cereals, dairy products, meat, poultry products. Under that today we will see determination of physical properties of cereal grains. Objective to determine physical properties of cereal grains. Its relevant information is like data on physical properties of grain is essential for the design of equipments for handling, aeration as well as storage as well as processing cereal grains. The most important such properties are the grain dimensions are size, 1000 kernel weight, percent dockage, color, hardness, kernel density, functional porosity, angle of repose and degree of sphericity. Materials required will be cereal grain, vernier caliper, weighing balance, photographic enlarger, measuring cylinder. Procedure first one grain size. It is also a factor related to quality of product. It also gives the indication of varietals purity. Classification rice or paddy are generally carried out based on length or width ratio. Procedure count 20 cereal grains from sample randomly. The length width is measured by vernier caliper or photographic enlarged to of each of the 20 grains and expressed as A and B. The length of ratio can be calculated using the following equation: length to width ratio, average length paddy by average paddy width. Observations: name of sample, length of paddy grain, width of paddy grain, L by W ratio. 1000 kernel weight. In handling and processing of grains, it is customary to know the weight of 1000 kernel. The 1000 kernel weight is a good indicator of the grain size, which can vary relative to growing conditions as well as maturity. Even for the same variety of a given crop, when compared with other crops at the same moisture level, the 1000 kernel weight will also provide an idea of relative size of the kernel for handling purpose. Procedure: from the sample of paddy grains supply, count 1000 whole grains randomly, take accurate weight of these grains on a precise balance. Observation: name of the sample, weight of 1000 kernels in grams. Percent dockage. Dockage includes chaff, stones, weed, straw, seeds, soil, raw rice straw, stacks, and other foreign matter. These impurities generally come from the field or from the drying floor, as in developing countries, paddy and other cereal are harvested by traditional methods. Technically, impurities are called as dockage. Separate the chaff, stones, weed, seed, soil, rice, straws, stacks, and other foreign matter. Then weigh it and calculate their percent, which is inversely proportional to the grain quality. Procedure: weight of the sample, weight of the foreign matter, stones, and weed seed removed. Calculate the percentage dockage will be the weight of dockage by the total weight of the sample into 100. Observation: name of the sample, weight of dockage, 5 dockage. Color is most appealing factor for any customer to decide the quality of product. It may differ from variety to variety. The color of grain is measured by Munchel color chart. In colorimetry, the Munchel color system is a color space that specific color based on three color dimensions: hue, value, lightness, and chroma, color purity. The system consists of three independent dimensions, which can be represented cylindrically in three dimensions as in irregular colors: solid, hue measured by degree around horizontal circles, chroma measured radially outward from the neutral gray vertical axis, and value measured vertically from 0 black to 10 white. While using color chart, the grain samples are compared with the colors on chart. The color of the grain is then expressed in the values of hue, value, and chroma. A color is fully specified by listing the three numbers for hue, value, and chroma in that order. Observations: name of the sample, color of the grain. Hardness. The hardness of grain is related to quality of product with respect to shelf life. It is factor which is related with the moisture and protein content of grains. If the moisture content of grain is less, the grain will be harder and vice versa. If the protein content of grain is less, the grain will be softer and vice versa. Traditionally, the hardness is checked by breaking the grain by teeth. In laboratory, hardness is checked by hardness tester. Grain is placed in tester and pressure is applied on the grain with the help screw, and pressure is noted down in kg per centimeter, which the cracking noise is heard. Observations: name of the sample, hardness of the grain. Color is the most appealing factor for any customer to decide the quality of product. It may differ from variety to variety. The color of grain is measured by Montiel color chart. Density: the kernel density of a grain is defined as the ratio of mass of a grain sample to solid volume occupied by the sample. For the determination of kernel density of an average grain, two methods have been suggested. One involved the displacement of a gas, whereas the other used displacement of a liquid. In both methods, Archimedes' principle of fluid displacement is used to determine the volume. Density of grain is related with its packing and storage properties. It is the ratio of mass and volume of the product. Procedure: weigh 20 grams of sample. Take a 100 ml capacity cylinder. Add solvents like kerosene or toluene of known volume, that is 50 ml. Add previously weighed grain sample to the solvent. Note down the increase in volume. Calculate density, that is weight of sample divided by increase in volume, gram per ml. Observations need to be right. Bulk density. The bulk density of cereal grains it is determined by using the weight of a grain sample of known volume. The grain sample of placed in a container of a regular shape, and the excess of the top of the container is removed by sliding a string or stick along the top edge of the container. After the excess is removed completely, the weight of the grain sample is measured. The bulk density of the grain sample is obtained simply by dividing the weight of the sample by volume of the container. The bulk density gives a good idea of the storage space required for a known quantity of particular grain. Procedure: take a 100 ml capacity of dry measuring cylinder. Fill the measuring cylinder till 100 ml mark with the grain. Take out the grain and weigh it. Calculate the bulk density as follows. Bulk density is equal to weight of grain divided by 100 ml. Porosity, it is defined as the percentage of volume of intergrain space to the total volume of grain bulk. The porosity of grain is an important parameter that affects the kernel hardness, breakage susceptibility, milling, drying rate, and resistance till fungal development. Porosity depends on the shape, dimensions, roughness of the grain surface. First measure density and bulk density of grain and calculate porosity by using the formula. Porosity is equal to true density minus bulk density divided by true density into 100. And angle of repose, the flowing characteristics of different grains are different. It is characterized by the angle of natural slope. The angle of repose is the angle between the base and the slope of the cone formed on a pre-vertical fall of the grain mass to a horizontal plane. It gives a frictional properties of grain during storage and transportation. Angle of repose is less than the angle of hop. Prepare a heap on a circular base of known radius so that grain should be separated out of circular, and then measure the height of the heap and determine the angle of repose by using the formula tan inverse h by r, that is height by radius. Degree of sphericity. The shape of the rice was found to be cylindrical with the three perpendicular dimensions: length, width, and thickness. The physical dimensions were determined randomly measuring length, width, and thickness of the kernels using vernier caliper. The criteria used to describe the shape of seed are the sphericity and aspect ratio. The sphericity was according to computed as sphericity is equal to LWT to the power 1 by 3rd by L into 100. So likewise we will be doing so many physical test of cereals by using uh, natural subjective methods of human being. Okay, these are the different tests by which we will be determining the quality of samples, and we will be finally concluding that the sample is having good quality. Thank you very much for your patience listening.